Good morning. So I want to talk a little bit about technologies for trust and identity management, following along a lot of the really wonderful information that was revealed this morning. And we've already heard about how online identity itself has evolved. So I won't dwell on that so much. It all began when we needed to log into computers and then log into websites, and then we had this notion of single sign-on services that people are familiar with. And then, as was described this morning, we had the notion of federated identity, which links identity across multiple distinct siloed identity systems. And you're familiar with that, with the concept, the OAuth concept of exemplified in logging in with Facebook or Google or whatever. But now we've got, I think, a radically different approach to identity. It doesn't really follow quite in line with any of the predecessors here. And this is what I want to talk about. So there is a relationship between decentralized identity and self-sovereign identity that people talked about this morning. Self-sovereign identity is not all that well defined. It's being defined now by a number of different companies that are working hard on it, but it is the concept of an identity that can be controlled by an individual person. And it works well with decentralized identity systems, but I want to talk more about other aspects of decentralized identity, and perhaps we can talk at another time about self-sovereign, because it's quite fascinating. But the other aspects of decentralized identity are applicable not just to the entity of people, but all sorts of other kinds of entities that need to have identity, including devices and software and other entities that can act for an individual. A lot of this is all driven by the idea of having a lot of automation of all kinds of processes, whether they be processes in Internet of Things or processes having to do with e-commerce. But the automation is basically requiring us to identify all the different kinds of entities that are requesting that actions be taken by some globally automated system. And so a lot of our identity management approaches probably need to deal with identifying not just the individuals involved, but the various kinds of attributes as well. And so there's lots of dimensions of decentralization. These identity attributes, some of which people talked about this morning, are decoupled. That's an aspect of the decentralization that we're talking about. And they originate from lots of different disparate places, which should represent the most authoritative sources for those identities. And so you've got authoritative sources for the identity of various kinds of devices, for various kinds of software, for various kinds of licenses, subscriptions, all of the different kinds of things that we interact with nowadays have identities, and somehow or another we've got to find out who the most authoritative knowledge is, or the people with the authoritative knowledge about the attributes of those entities need to be able to record the identity and linkage information about them. Decentralization of identity data, the actual databases that hold the identity information, that also, if it's decentralized, can be made much more robust and scalable than it is already. A lot of things are kind of slow nowadays simply because of the fact that we're spending a good amount of time on protocols that seek to prove different kinds of identities, and that's something that we can improve upon. And also, attribute decoupling can allow for privacy, and privacy is something that's slowly slipping away, and we do believe that we can improve in that dimension as well. So as we build systems going forward, we want to be able to minimize the use of identity. We might want to make it possible for an application that wants to use your identity or the identity of a device you have or what have you in some very, very minimal way and doesn't collect information that it doesn't need. And finally, it would be nice to sort of humanize identity management somewhat, make identity policies kind of behave the way that they do in the real world. We each exercise our own judgment. We each have our own policies about what we trust and what we don't trust. And that's something that we ought to be able to make possible going forward. So identity attributes, some of these were reviewed earlier, and I'm not going to go over them in detail, but you've got all kinds of identifiers, starting with just simple names that could be globally unique, or they can be unique within a specific context. The biographic information, biometric characteristics, et cetera, and also in these modern times, the cryptographic objects that get linked to these kinds of things, the public keys, the public key fingerprints, and of course the accompanying secret keys. And then you've got all kinds of qualifiers, the qualifications of an entity, achievements of the person, compliance claims for devices. All of these kinds of things are things that can be linked to identity, and something that when we make a decision, an application makes a decision, we may want to see what these qualities are and verify that, in fact, they are linked to the entity we think they're linked to. And then we have privileges and ownership, which also goes into various kinds of decision making. And then finally, an important part that we'll hear a little bit about later on, it's provenance information. Who took that photograph or that video? Was it modified in any way? If it was modified, how was it modified? What kind of software operated on it? Things of that sort are going to be important going forward. Otherwise, we're not going to be able to trust anything that we actually see in presentations from the internet. So this kind of information also needs identity management. So what is a decentralized identity system? Very simply, it's an open system whereby any established authority can usefully record an assertion such as this entity with these verifiable attributes, take one or more from the list in the previous slide, also has these additional attributes, some new attributes that you want to bind to the identity established in the first part of the phrase. And then there's another part of this, which is an open system where anyone can verify that such an assertion whenever they are. And you'd also want to be able to preserve the confidentiality and privacy of the principal or subject that the assertion is talking about, when that makes sense to do that. So a decentralized identity system wants to make it very easy for people who with real authority about a subject that has to do with identity to record assertions about identity. And then another part of the system, at the very least, needs to make it very easy for applications that want to make decisions based on policy that reference these types of assertions, that information is available to them instantly. It's fresh information, and if it has changed, it's even refreshed before the decision is made. And that's a daunting task, but that's the purpose of this kind of identity system. What about the role of trust? Well, we need to trust others. I mean, we can't have efficient systems without that. And even though I'm going to talk about the use of technologies such as blockchains that are said to establish so-called trustless components or trustless systems, I personally don't believe in those. I think the only thing you do when you try to establish a trustless system is move around what it is that you're trying to trust. So we know that we need to trust others. We can't do everything ourselves. And we have reliably used trusted intermediaries in the past. So our aim is to make systems more trustworthy rather than trustless, and make the claims that we want to be able to rely on easy to verify. In other words, in the words of a famous American president, trust but verify. And so that's part of what the identity management system of the future is going to be. And we're going to need to do this really carefully and apply principles whereby we don't do things that we don't really have to. We don't complicate things more than we have to. And we make things as transparent as we can. There's an old saying, to err is human. Now it is an old saying. But to really screw things up, you need a computer. But to invite global catastrophe, you need a scalable, trustless, distributed system. And that's, if we don't get this right, that's the kind of thing that will happen. It's something that we know that we do as technologists. We plow ahead sometimes without understanding entirely what the consequences of what we're doing are. So the admonition here is to be very explicit and cognizant of what we rely on. That is, what is it we trust when we introduce a new system? So we've put together something we call trusted, immutable, distributed assertion electors, or titles. They're trusted, not trustless. These are essentially blockchain structures that you're going to be trusting because you rely on the ledger for important things. And blockchain transactions, for example, are said to be trustless. We don't make that claim. This is something that we want people to actually understand what it is that you're relying on and what policies are used in the establishment of an online distributed ledger. It's immutable, as blockchains tend to be. It's distributed in a number of different senses. But in our case, we're going to specialize in assertions, the bindings, and in particular, the types of assertions which are the bindings of attributes. So we're not going to try to solve lots of extrinsic problems, such as the double spending problem and things of that sort. That simplifies things tremendously. It allows us to provide much, much better performance. And then it is a ledger. It is something that you'll be able to reference when you want to make decisions about just about anything that relies on the kinds of assertions I talked about. We also introduced something called title derivatives. And these essentially are sort of the meat of what the ledger is about. But it's the minimal meat. It's the hash tables associated with all of the different assertions. So all of the different assertions are hashed, and you can put them in a table which kind of distributes them in a very, very regular fashion and makes it very, very easy to search so that you can verify the assertions that you're presented with, when somebody asks you to take an action. They can be distributed and synchronized, they can check one another, they can be constructed and maintained by entities focusing on specific types of applications. So this is the part of the system that faces applications and tries to make it easy for people to verify reliably assertions that they need to rely on. And as I said, typically they're just hash tables. And that makes them very easy structures to deal with. And it makes their interactions with them very, very straightforward. So for example, if your application is web browsing or trusted or secure web browsing, and you want to make sure that your DNS and SSL key validity are proper, then you can do a single lookup in a relatively small hash table that fits on about half of your cell phone nowadays. Of course, you wouldn't necessarily need to put it on your cell phone, but it could be hosted just about anywhere with multiple cross-checking copies. And so an important aspect of what we're talking about here is that we're going to have a lot of different kinds of ledgers. And those ledgers are going to be characterized by the different policies that make sense for recording the information according to what type of information it is, what the area of assertion, what type of attributes need to be verified, et cetera, or recorded. And so you'll have the concept of ingestion, and if somebody submits an assertion, there's a policy that is used to determine whether that assertion is acceptable. Should be recorded in that particular title because people are going to rely on this. So very explicit policy is published about the title. It says, this is how we're verifying the assertions that are submitted to us. Not just anybody can submit them. So the identity of the submitter is going to be checked out, and the authority that they have over the type of information that's being selected will also be typically included there. So this is a permissioned kind of ledger or permissioned blockchain, if you will. And a lot of those things that the policy references are going to be verified by making calls to other titles or what we call title derivatives. And so you have a kind of recursive application of the use of title databases. And then you have another kind of policy called an agreement policy, which has to do with how to take the multiple copies and the multiple verifiers and all of the findings that they have and make a decision as to what to actually write into the ledger. And that can be very, very different, again, depending on the type of information that's going to be recorded. And that's something that in, for example, Bitcoin, you have a specific policy for doing that. It's well published, and there's reasons for doing it for Ethereum and all the different kinds of blockchains that you have. You have it. We're talking about having probably tens of thousands or hundreds of thousands of these with very, very specific and very, very specialized policies. And then when an application wants to read from that database, they'll typically read through, like I said, something that filters the information, a trusted thing called a title derivative that will organize the information for them in a hash table. And, but an application will reference an application policy to determine what title derivative to really reference to gather the information, the trusted information, in order to make a decision. And I won't have time to go over this slide, but the idea here is that an application can reference lots of different titles and lots of different derivatives, and a single derivative, on the other hand, can gather that information for the application. And a lot of the applications that are things like any decision in any application where an action request is subject to security policy. Who made the request? What authority do they have to take this action? And like I said, titles themselves have those kinds of questions to answer. But applications that also need to check the provenance, the origin information of data, for example, the authenticity of sensor information, videos, photographs, audio, any signal that you can imagine, you want to be able to very, very quickly reference the authenticity of those things before you make a decision. And later on this afternoon, my colleague is going to talk about the ability to use these kinds of structures to be able to enable everybody who's watching any kind of online video to authenticate each of the segments, the 1 or 2 second segments, to determine whether or not it's authentic. And you have to work very hard to make sure that you have a scalable system to be able to do that. And because of this notion of introducing title derivatives, we're able to do that. And so you have the idea of a global infrastructure with many specialized titles, each of them having, in this diagram, something called title nodes, which are nodes in a blockchain, and then a concept of derivatives and the concept of the applications that reference the information. And they all interact with one another, but their policies are highly specialized. And so it's a market-driven producer-consumer model for trusted information. The titles are optimized to record specific types of authoritative assertions. And there are many title derivatives that are optimized to support the specific kinds of applications that get the information in that producer-consumer model. Technologies are blockchains that are used as tools supporting identity management applications. We're not trying to put this into a blockchain like Ethereum or anything like that. We're just going to use blockchain concepts such as what Stuart talked about this morning as a tool to accomplish a very, very specific task. Policies are the important variables, and registrations authorities are going to be needed for the roots of trusts and namespaces and things of that sort. And other tools such as zero-knowledge proofs can also be used in a system like this. And then finally, I want to say just a couple of words about privacy. Distributed identity systems allow for a lot more privacy options. Contextual attributes can be used more often. You don't need to know, certain identity attributes in order to take certain types of actions in a specific situation. Verification databases only need to keep the hashes of the public keys in contextual ID fragments and the bindings of those, which are the things that you really need to understand. So you don't actually need to even see the plain text information in those public databases. But somebody who says, is this binding correct, can look to see whether or not there's a hit in the hash table to determine that, yes, that's valid information. And the derivative will take care of things like revocation and updates and things of that sort. And then you can use things like privacy keys, which can actually help make that even more confidential. And then, again, ID as for an application can be as minimal as possible. And then finally, there's notable work from lots of other companies, some of whom have been talking to us today. Hyperledger Indy is one of the more active projects that you'll see out there for distributed identity. Microsoft has a very active and very interesting identity or distributed identity and self-sovereign identity approach to things. We heard from the OpenID Foundation. There's something called the Sovereign Foundation, and then, of course, FIDO is another organization that has put together a lot of very interesting technology that supports a lot of what I just talked about. Thank you very much.
ありがとうございました。どうぞ大きな拍手でお送りください。